Hey, this is the most important and critical to think to hit the inclusion problem that I solved recently, which is coin piles. So basically, he says that we have an array and k value. We have to, each array element represents the number of coins present in each pile. So this is the first pile and this is second pile, like that. And first pile contains only one coin, pile contains only five coins, like that. And he wants us to make the array, remove some elements inside these array such that after removing the absolute difference of any two adjacent elements has to be less than or equal to the k. That means at most k. So that's we want to ask, and we need to return how much minimum elements we have to remove. That means minimum number of coins we have to remove among these elements of the array. So how can we get it? Initially I thought we have to iterate we have to iterate on complete array, and then we have to take an element, and then we have to iterate again. So now we are taking the first element in the first loop, right? And for every next element of these element, like how can I show that? Let me write the intuition. So initially I have to write the for loop from 0 to n, right? Because indexes are represented with 0, so this is 0 technically. And now I have to write again another for loop, which is again start from I plus 1 to n. So here my second for loop is starts. Now the difference of these element, calculate the difference, which is equal 5 minus 1 is equal to the 4. Oh, so is the difference is greater than 3? Yes, of course it is. So you have to remove one pile, or you have to remove one pile from this. So the uh, count is plus 1. So c plus plus is nothing but like c is equal to c plus 1. Count is plus 1. Got it? So and after you comparing these thing with the uh, jth of first element, and you have to keep moving that jth element and finding those differences. But this intuition is completely wrong, right? So that's what I want to talk, because he says that the adjacency element, right? Adjacency element difference has to be less than or equal to k. So we have to take care about the adjacency elements. So after calculating the 1 5, we have to see 5 and 1. And when you changing the like when you remove one element from this pile, so it will become 4, right? So now you have to compare, you have to find the difference between the 4 and 1, not the 5 and 1, this thing. So it makes clear, and we can do that with the for two for loops. We can do that because we have to know, we have to see the difference between the adjacency element, this thing, and then the difference between these adjacent element, and update this element, right? So now difference between adjacent element, these three adjacent elements, like that. And after getting that, we are not sure that we are actually getting the minimum number of count to remove the entire element, to make the constraint satisfied. So that's why we need to think about a particular approach which approximately give us the answer minimum number of coins we have to remove from these piles, you see. So, and he says that the constraints are like, whenever we are getting this kind of questions, we have to see the constraint. So here the constraint is 10 to the power of 5, and each element may be 10 to the power of 4. So forgettable the elements. How many elements we have? 10 to the power of 5 elements. So it make so 10 to the power of 5 and into 10 to the power of 5, it is nothing but 10 to the power of 10. So which is actually greater than 10 to the power of 8, right? So it won't be accepted. Yes, it won't be accepted. It gives tally if we are using more than one loop. So either we have to think it in big of n, or big O of n log n. So both two are acceptable. So big O of n log n. So when we are getting the big O of n log n, we are getting big of n log n for sorting things. So we need to sort this thing. So and we got 1 1 1 and 2 and 5 5. So okay, we are sorted. But the question says find the adjacency difference, right? Adjacency difference and remove the coin whenever those difference is greater than k. And why you are finding, why you are keep sorting? If you sort, the positions of the elements are changing, right? Here, that's not about what we have to bother. We have to bother to get the minimum count of coins which are going to be removed. So we need to think in count way. So for suppose, if one is here, right? So what is the limit of one such that the difference has to be always less than or equal to k? So how much we can add to the 1? So in order to get the limit, 1 plus k, so 4. So in these array up to 4 we are already sorted, right? So up to 4 we don't have a problem. And when we are getting the element which is greater than 4, then we have to reduce our count value. I mean, increase our count value, because you need to know the count value, right? So that's why I'm adding k value to the current element, which gives me the 4. So now I have to check whether the element at what place I am getting the value which is greater than 4, which is here in this index. So it is nothing but fourth index. So that means from 0 to 4 the elements which are present are actually satisfying the condition, and from 4 to whatever the length, it may be n or m, whatever it may be, so these elements are actually not satisfying the condition, the constraint. That's why we need to know how much elements we can remove from these set, and we have to add that to the answer. So that's it. And how you are actually know that? So if you know something big value, and you know something which you want to know after removing certain thing, and that certain thing is, I can represent that as y. So how can you know that? It is simply x minus y, the certain thing that you want to know after removing particular thing from the whole thing, right? So for I mean, here also we need to follow the same approach. So we know how many, I mean, we want to know how many coins we have to remove from this set. Okay, so we are actually know what the limit. The limit is nothing but 4. So the limit is nothing but 4, and here how many coins are present? How many piles of coins are present? First, we want to know how. Yes, just here we are know the total, right? So here we want to know the what total number of coins are present, and how you know exactly? We have to count these two. So 5 plus 5, which is equal to 10. I'm having 10 coins here. Okay. Now what? The certain thing. What is a certain thing here? How can you get the certain thing? With the help of this limit, because this limit only makes the differentiate, right? So is that differentiate is 4? No, 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 no. For, I mean, for each, I mean, adjacent element, I'm having how many number of those adjacent elements? 2 elements. That's what, right? So 2 elements, 2 adjacency elements. It's nothing but number of piles, right? And how many coins I have to, I mean, up to how many coins, which makes the thing satisfied? 4. But to force the 8, but I'm having 10 coins. I need only 8 coins. So how much coins I have to remove? Simply minus, you will get 2 coins. So here you have to, up to in this region, you have to remove 2 coins. You don't need to remove 8 to remove that coin. That's what the question says. If the question says, okay, give me the indices where I have to change the coins, I mean decrease the coins in that, such that the minimum the adjacency element of everything has to be less than or equal to the k. Then if he asked about the position, then we have to store those indices and keeps I mean whenever we are getting up to here the process is same, and when we are here, so we have to see those indices and update our answer with that indices we have to use. So here, yeah, this is what approximate. So whenever you are getting, so okay, two coins, so add it two. Now so here also you are getting two, here also you are getting two, here also you are getting what? It's not two, because see here, 2 minus 5, the answer is 3, which is less than or equal to the k value. So it's okay, it is also okay. So then what? Then the left part makes the problem here, not the right part. Right part satisfied. So whenever you are at particular element, you have to see how many elements you have to remove from the left and how many elements you have to remove from the right. That's what we have to do here. So if we are at here, so how many elements I have to remove from left? 3, and from right 0, because everything is satisfied. So 3 here, the for 2 the answer is 3, and if I choose one, the answer is what? 2. And what is the minimum among them? 2. So that's why the answer for this is 2. Got it? So if you remove this thing and this thing, we get it makes everything satisfied. And you see, in the middle of the question we need to find the sum of a total number of elements present inside the array. And how we are getting that? Do we have to iterate from whatever the indices, starting indices up to the ending indices? It makes the things complicated. When you write the for loop inside certain number of process, it increments the complexity, right? So the the only way to avoid this is using prefix sum. So you need to do the prefix sum. 1 1 1 2 5 5. So 1, and prefix sum, it will give 2, it will give 3 5 10 15. So directly when I'm here, I have to find the greatest indices, uh, 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 yeah, the first indices which makes my limit, which has the element which is greater than my limit, so which is nothing but here. Okay, so now how many elements are left? Just watch the indices, which is 15, and you are getting how many elements are left here, and how many piles are there. By just get the difference, like 5 minus 4 plus 1, which is equal to the 2, because this is how you are getting the length of the sub array, right? So I'm just having that length of the piles here. How many piles are there? So 2 piles, 2 into, and what is my total count? 15. And this, the 15 represents the entire sum, and I only know the sum from what index? From fourth index, right? So remove the sum up to what? Up to 4 minus 1, which is 3, so which is equal to 5. So 15 minus 5 is equal to 10 now. So that means the sum is 10 from that index to up to the end, and we have two elements. Just we have to remove we have to remove I mean, we know the total number of elements, and we know the constraint, and how many elements, I mean, what is my limit? So for 8, so at max I can remove the 8 elements, I can store the 8 elements, but here I have the 10 elements, so subtract them, you will get the answer as 2. So see, this is amazing way, but it makes you think. That's why I want to make a video on this.